In this video, we will be working through the process to create the simple bookshelf project. This project consists of 15 parts. Our project plans consist of 2 sheets. The first sheet is our multi-view drawing, and the second sheet is the exploded view of our project. Taking a look at our plans, we can identify both the left and right side. The total depth of our project is 13 inches. We do have a 1-inch overhang, which then brings the base of the project to a total depth of 12 inches. Now we also have a 3/4 inch thick face frame, which will bring the left and right side down to 11 1/4 inches. The height of our left and right side is 47 1/4 inches, and this is using 3/4 inch oak veneer plywood. We do need 2 of these. If we take a look at our cutting diagram for plywood, we should be able to get all 3/4 inch plywood components out of a half a sheet of plywood. So this project will begin with 3/4 inch thick oak veneer plywood and a half a sheet, so it is measuring 48 inches by 48 inches. Taking a look at the rendering of our finished product, we can see that the grain is running vertically. It is also running the same direction as our length measurement. If we take a look at our plywood sheet, that 47 1/4 inch measurement needs to go with the grain. On our plans, the depth measurement is 11 1/4. So on our plywood, we will want to rip this at 11 1/4 inches along the length of the grain. And because we have 2 sides, we will need to make 2 of these cuts. This also correlates to our cutting diagram for plywood. On the table saw, we will set our fence to 11 1/4 inches. And we do want to make sure that we are cutting with the grain so that grain is running the long way on our project. To set up a stop block for the miter saw, I'm first going to measure my 47 1/4 inch length, and I'm going to line that up with my saw blade. And on the other end of my board, I'm going to install a stop block with a square end and 2 clamps. I can then move the miter saw head nice and slowly through my material. This will prevent chipping of the veneer. And this process can be repeated for our second side. Taking a look at my schematic, I have 1 bottom shelf. This shelf runs from the left side to the right side, and it fits between these sides. My total width of the project without the top is 24 inches. My left and right side are 3/4 inch oak veneer. So if I take my 24 inch width measurement and I subtract the thickness of the left side and the right side, that gives me a length of 22 1/2 inches. The depth of our project is 12 inches. My face frame is 3/4 of an inch, but I also have a 1/4 inch back on this project. So 12 inches minus 3/4 for my trim and a 1/4 inch for the back gives us our 11-inch width measurement. With my remaining material from my 1/2 sheet of plywood, I need to get the bottom shelf as well as 3 additional shelves out of this material. Setting my table saw to 11 inches and ripping my remaining material to that 11-inch measurement will yield me the material that I need for this one bottom shelf. I'm going to measure this to a length of 22.5 inches, mark it, and then very slowly make my cut. Taking a look at the exploded view of our project, the bottom gussets are located underneath the bottom shelf. These bottom gussets are what will take the load of that bottom shelf. They are designed to go on the inside of the project behind the face frame. Taking a look at our parts list, we can see that the bottom gussets need to be 2 1/4 inches wide by 11 1/4 inches long. Additionally, having a thickness of 3/4 of an inch. By selecting a board that has a width of 5 inches, I should easily be able to get 2 1/4 inch wide pieces out of this, with leaving me a little bit of extra material for cleaning up the edges of this board. The end of my board has a couple issues. Number one, it is not square, so I need to make sure to square this up on the miter saw first. Additionally, I have a corner that doesn't look very good. However, this is not an issue because if I lay out both of those gussets, I might not even get to that corner. Additionally, since this will be planed down to 3/4, that piece should be eliminated. So my first cut will be to square it up and then perform that next cut. Taking a look at my board, I have one bad corner. So I want to try to get both of my gusset pieces from the other side away from this corner. My finished width is 2 1/4 inches. However, I'm going to add an additional 1/16 of an inch so I can joint that off after it's been table sawed. And with my good, clean, jointed edge up against the fence, I can make my first cut. And another pass on the table saw at 2 5/16 will yield me that oversized width. That mill marked edge, I'm then going to run through the joiner. I'm going to mark both ends of my boards, take off as little as possible to guarantee that the end is square. Measure 11 1/4 inches from my good end. Set up a stop block to that measurement and then make both of my cuts. Double checking that we are cutting off the pencil marked end of our board, not the good end. Because one of my boards has a bad corner, I will be planing a lot more material off of this face to bring this down. But either way, I will be planing both sides of both pieces. Now at this point, we do need to determine which side we want facing out on the project, because our gusset pieces are going to be adhered to the inside of the project. We then want to add a little bit of glue to the face of our bottom gusset and spread that around across the entire face. We can flip that over and apply a couple clamps to hold that securely in place. We do want to double check that we are perfectly flush with both the bottom of our project as well as what will become the front of our project. And then wipe any glue that has squeezed out. This can then be set aside for 24 hours. And we need to continue the same process with our other side. With the glue dried on our bottom gussets, we can dry fit the bottom shelf in place just to make sure everything lines up. And if you remember from the parts list, our left and right side are 11 1/4 inches, but our bottom shelf is only 11 inches. And we can see that when we dry fit this together. That will accommodate our back 1/4 inch veneer sheet and give us something to adhere that to. With everything looking good, I can fold my project back down, apply a little bit of glue to the top of that bottom gusset piece, as well as a little bit of glue on the side where my bottom shelf connects to it. Doing this for both pieces. I can then very carefully assemble this together and install one clamp on the back with just a little bit of pressure. Flip our project over and install another clamp. And we want to double check that the front edge of our project is perfectly flush, meaning the front edge of the bottom shelf is perfectly flush with the front edge of both our right and left side. This will then need to sit for 24 hours. Taking a look at our schematic, the top rear rail cannot easily be seen. If we look at the exploded view, we can see that it sits up inside all the way at the top towards the back of our project. The measurement of our top rear rail is 3/4 of an inch thick by 2 inches wide by 22.5 inches long. I'm going to measure and mark this at 22 3/4 inches. This is an oversized measurement, and then make my cut. I'm going to go ahead and joiner my rough edge 2 or 3 times until that's cleaned up. And I'm then going to set my table saw to 2 inches plus 1/16 of an inch so I can joiner off that milled edge once it's been cut. And with my good, clean, jointed edge up against the fence, I can make my cut. I'm going to joiner my mill-marked edge, which will bring that down to 2 inches in width. We want to make sure that both ends are perfectly square, so I'm going to mark both ends of my board. My first cut will take off as little material as possible. I then want to mark 22.5 inches and complete my second cut. Because there is only one of these pieces, we do not need to set up a stop block. With the thickness planer, we can plane both sides, slowly bringing the machine down, measuring our board routinely, until we get down to 3/4 of an inch thick. Now the issue is we have end grain that we are trying to connect to our plywood sides. Because end grain doesn't glue, we need to add some mechanical fasteners. We will be adding a couple pocket hole screws from the back side. And our objective is to space out the pocket hole screws so we have a good connection point along the width of this piece. We can dry fit this together on our project to see how it will be installed. We want to make sure that the pocket holes are facing the back of the project or facing what would be the wall, but we also want to install this 1/4 of an inch inside from the back edge of our project. And we can install 2 pocket screws. Taking a look at our schematic, we can see both of our front stiles, which run the height of our project. The height of the project without the top being 47 1/4 inches. The width of each of these stiles is 2 inches, and the thickness is 3/4 of an inch. Out of my 50-inch length board, I should be able to get both of these 2-inch wide front stiles. I have previously squared up the end of my board in a different step for making a different piece for this project. So I'm going to measure and mark my board to an oversized length of 47.5 inches. And then make my cut. I'm going to set my table saw to 2 inches plus a 1/16, and with the good, clean, jointed edge up against the fence, perform my first cut. I'm going to joiner both of my mill-marked edges, and then that off-cut piece can go back through the table saw with the good, clean, jointed edge up against the fence. And then we'll clean up that mill-marked edge on that second stile. We can start by marking both ends of both stiles. Our first cut on the miter saw will be to take off as little as possible just to square up the end. We then want to measure our board and mark it at 47 1/4. A stop block will ensure these are cut to the same measurement. We can then cut both of our pieces, making sure that we are cutting off the marked end. Taking a look at our plans, we have one bottom rail kick plate. This piece goes in between our stiles. Our total project width without the top is 24 inches. We know that our stiles are 2 inches wide. So subtracting both of those stiles puts this piece at 20 inches in length. The width of this piece is 3 inches, and the thickness will end up being 3/4. So with this planned out, we can go ahead and square up one end, measure and mark our board at 21 inches, and perform our second cut. I'm going to run that through the joiner a couple times to clean that up. The table saw will be set to 3 inches plus 1/16. And with my good, clean, jointed edge up against the fence, I can make my cut. I'm going to clean up my mill marked edge on the joiner. This will take off that additional 1/16 of an inch. And for the time being, we are going to leave this at our oversized length of 21 inches and move on to making the top front rail. If we take a look at the schematics, our top front rail is at the very top of our project on the front. This piece measures 2 inches in width, and we can determine the length by finding the total project width, not including the top, of 24 inches, and we can subtract both of our 2-inch wide stiles from that measurement. This gives us a finished length of 20 inches by a finished width of 2 inches by 3/4 of an inch thick. I have a piece that measures about 23 inches that I have left over from a previous portion of the project. 23 inches is a little long. I could leave this at that since I am cutting it down again later, but I want to be just a little bit closer to what I need it to be. So I'm going to measure, mark, and cut this to an oversized length of 21 inches. Joining the edge opposite of the knot one time to clean it up. Set my table saw to 2 inches plus a 1/16, and with my good clean jointed edge up against the fence, perform my cut. I'm going to clean up my mill marked edge on the joiner, which will also remove that 1/16 of an inch. This piece will also be left at an oversized length until we get the stiles installed on our project, because this goes between the stiles. Taking a look at our plans, we can see that the thickness of our face frame components, the stiles and the rails, are 3/4 of an inch thick. Currently, all of my pieces measure about 1 inch thick. Because we want all of our face frame components to be perfectly flush on the outside, I need to make sure that I am planing all of these pieces at the exact same time so they have an identical thickness. Taking a look at our schematics, we can see that the front stiles are attached to the front edge of our project. Although as it is drawn up, our front stiles are perfectly flush with the side of our project, we're going to leave just about a 32nd of an inch overhang when we install these. This little overhang will be able to either be left or flush cut off after installation. We'll begin by applying a little bit of glue to the front edge of our sides. We want to make sure that the glue is spread evenly over the entire surface. We can then set the stile in place and very carefully work down the length of the project, installing a series of clamps, making sure that we have about a 1/32 inch overhang of our stile onto the side. After 24 hours, we can remove our clamps and set up for our other side. A little bit of glue and more clamps. Again, making sure that the bottom and top are flush, and we have about a 32nd inch overhang down the length of the project. I had previously cut my bottom kick plate rail to 21 inches, which was substantially more material than I needed. And to size this down, I'm first going to start by marking each end of my kick plate rail. I'm then going to square up one end by taking off as little as possible. I'm then going to line up my good square end with my left style and put a mark where that meets my right style. With my top front rail, I'm also going to mark the ends. I'm also going to square up one of the ends by taking off a little bit first. And with the mark previously made on the bottom kick plate, I'm going to set up a stop block to that measurement and make that cut. And if done correctly, this should have a nice tight fit. We can then cut this out on the bandsaw, making sure that we leave the line so we can sand down to the line. A few relief cuts will help us in the process. We can then clean up that radius on the spindle sander. But then I'm going to use my stop block at the same setting to do my second cut. This will ensure that the sides remain perfectly parallel. Our two pocket screws need to be positioned to clear the lower shelf, but still allow us a positive connection between these two pieces. On the top front rail, we do not have that same concern, so we just want these spaced evenly apart. And we can then cut all of those pocket holes. We can install a couple bar clamps along the length of this piece and install our pocket screws. Install our workpiece with just a little bit of light pressure. This then can be flipped back over, and we can install those additional pocket screws. If we take a look at the exploded view, we can see that the gussets are all the way at the top, all the way on the sides of the project. If our calculations are correct, these pieces should be 3/4 of an inch thick, 2 1/4 inch wide, and 10 1/4 inch long. I'm going to run my mill-marked edge through the joiner one time to clean it up. My table saw will be set to 2 1/4 inches plus a 1/16. And I can then joiner off that 1/16 of an inch mill-marked edge. And I can progress down to 3/4 of an inch thickness, measuring it periodically. On the miter saw, I'm going to start by marking both ends of my board. I'm going to take off as little as possible just to square up one of the ends. I'm then going to measure to 10 1/4 inches, mark my board, and then set up a stop block. And with my good newly squared end against the stop block, I can cut two pieces. Now I will have a glue joint running the length of the edge of the gusset, but I want an additional connection point on the ends of each of these gussets. So I'm going to mark for a pocket hole location, and I can cut those pocket holes. We can then apply a little bit of glue and install that top gusset. And we may have to shift the clamps around a little bit to install those pocket screws. Taking a look at our schematics, the top of our project measures a total length of 26 inches and a total width of 13 inches. This is then listed as 3/4 of an inch thick. I should be able to get 3 pieces that are more than 26 inches long and have enough width to get more than 13 inches wide. Making sure I start with a square end first. I can then measure, mark, and cut all of my boards to a length of 27 inches, which is an oversized measurement. Starting on the joiner, I'm going to clean up one edge of all of these boards. On the table saw, I'm going to have my good, clean, jointed edge up against the fence, and I'm going to remove as little material as possible so that I can create a parallel edge to my jointed edge. And with that extra board that I had found, I'm going to try to cut off as much as that defected area as I possibly can, yet leaving me the maximum amount of material to still use. I'm going to clean up on the joiner next. And for my board with all the defects, I'm going to come back to the table saw off the rest of that defect area, and then go back to the joiner and clean this up again. I have previously prepped all of the edges of my boards, and when fit together, there is a nice tight fit with no gaps. I want to make sure that the end grain is alternating down, up, down. Additionally, I want to make sure that the face grain looks nice. And when we got everything the way we want it, we're going to number the joints so we know what orientation the boards go when we glue it up. We can then run our bead of glue along the edge and work that around to get good coverage. And then we'll come back with a couple clamps on top. After 24 hours, we can unclamp our board, and any dried glue then needs to be scraped off from both sides. I'm going to begin by cleaning up one edge on the joiner. I'm then going to set my table saw to 13 inches plus 1/16, and with my good, clean, jointed edge up against the fence, make my cut. And then clean up that mill-marked edge on the joiner. Square up one end by taking off as little as possible. Then I'm going to measure and mark my top at 26 inches and make my next cut. I am only going to remove enough material to make this smooth. And with both sides cleaned up, I'm still sitting at about 13/16. Taking a look at the schematics, our pilasters run vertically inside our bookshelf. They run the entire length of the sides from the bottom shelf up to the top gussets. We can also see that they are not right up against the edge, they are sitting back just a little bit. It is also important to note that there are very faint numbers stamped into the pilasters. These numbers will help us determine the orientation as far as which end is the bottom and which end is the top. When I measure the distance inside our cabinet, I get a length of 43.5 inches. Next, we need to mark one of them at 43.5. And I'm going to set up a stop block on the miter saw based off of that one marked piece at 43.5 inches. I'm then going to stack the remaining 3 pieces, gently pushing them up against the stop block. Next, using a board of sufficient size, I'm going to place that on top of the pilasters and clamp that in place, making sure that the end of the board is as close to my cut plane as possible. Now, with having the correct blade installed on the saw and holding my material as tight as I possibly can, I'm going to very, very slowly make a cut through my pilasters. Again, the feed rate of the saw needs to be as slow as possible, and you should have the proper blade for this. And we can install our first screw. We want to install this slowly and tighten it just until it is a little bit snug. We can then continue that same process along the length of the pilaster. And with those pilasters installed, we're looking pretty good. If we take a look at our schematics, we have a 1/4 inch back that needs to fit onto our project. We have previously inset our top rear rail 1/4 inch to accommodate the back. We have also cut our lower shelf 1/4 inch narrower, again to accommodate this 1/4 inch back. With the project on its face and a rabbiting bit in the router set to the thickness of my 1/4 inch back material, I want to secure my project to the table and make my first cut. Our 1/4 inch plywood back has square corners. However, when we routed this, it left a radius and some other areas that we need to clean up. Using a chisel and a mallet, we can very carefully work those corners square. Our goal is that our 1/4 inch backing piece will fit nicely in that cleaned up corner. With the rabbet, the back of our project measures 23 3/8 by 45 inches. According to the cutting diagram, the grain pattern of the plywood needs to run lengthwise with our length measurement, that length measurement being 45 inches. So I will be setting the table saw to 23 5/16. And then I need to make sure that my cut is going lengthwise with the grain. Then we can measure, mark, and cut. And we can then set that in place to see how well that fits. And that fits really nice. We want to use a minimal amount of glue so we have virtually nothing to clean up on the inside of the project. We can then add our back, making sure that it gets seated fully, and double checking that the good side is facing in towards the inside of the project and the bad side is facing towards the back of the project. And we want to angle the brad nails slightly towards the side of our project rather than towards the inside of our project. Taking a look at our schematics, we have 3 shelves. The shelves run between the pilasters. They run behind the face frame, and they go all the way to the back of our bookshelf. And according to our parts list, these should be 3/4 inch veneer plywood, 11 inches in width, 22 1/8 inches long. Because we will be edge banding the front edge of the shelf, we're going to subtract 1/16 of an inch from our width measurement, and this should give us plenty of room for that edge banding. So I'm going to set my table saw to 10 15/16 and run both of my pieces. On the miter saw, I'm going to set up a stop block to 22 1/8 and then cut all 3 of my pieces. We have the plywood edge that we need to cover up. So we're first going to cut a piece of veneer edging just a little bit longer than the length of our shelf. We're then going to use an iron to iron on the veneer edging. And then we'll come back with a block and help press that down in place. Then we'll come back and trim off the tails and clean up both edges. And a little very light sanding will finish that up. And that process will be repeated for the additional shelves. I can then measure up about 10 inches on my pilaster and work one of those clips into position. And with all 4 of those installed, I can see how my shelf looks. And with our 3 shelves installed, everything is looking really nice. Now the good side of my top, I'm going to put face down. I'm going to remove my shelves and turn the cabinet upside down. And then my objective is to center the base of the bookshelf on the top, having a 1-inch overhang on the left and right side and a 1-inch overhang on the front. And on the inside edge, we'll put a couple reference marks. Then we can tip the project back. Next, we can apply glue to all of the mating surfaces and install it back onto our project. Lining up our reference marks. And I'll add a couple clamps to the front to hold everything in place. And wipe any glue. Now, because most people will pick up this project from the top, I want to make sure to use a mechanical fastener. So I'm going to drill a 1/8 inch pilot hole, having the bit set so it does not drill through the top of the project. We'll drill our pilot hole, a couple of those, and install a couple pan head screws. With our top on the base and everything dry, we're looking pretty good. The top edge of our project is very sharp, so we will be routering a profile to add a little bit of character and bring down the sharpness of this edge. And with that top edge routered, it's looking really nice. And lastly, we just want to do an overall general sanding of the entire project to prep this for stain.